Now, after we know everything about the confusion matrix, now it's time for us to write the program to find the confusion matrix. At first, the data that I will use today is the data from the UCI repository. Um, I will show you how can we get the data. Okay, let's start with breast cancer from the UCI. So this one is very popular data set posted in the UCI machine learning repository. The data is all of them are real values. That is, I think is quite good. So you can see that this one is real, and here um, there are, look at this, there are 10 attributes. All of them are real. So to show that this one is a paper that try to attack this data set. So guys, now we have like the data folder that you can go to this folder, and you can see that we have the breast cancer Wisconsin.data and breast cancer Wisconsin.names, and it has something like other data set, but we will easily use the breast cancer Wisconsin.data, and let's take a look. You can right click and copy the link and go to your sorry, go to your Colab. I post this Colab link in the description of this video, so no worry. You can get this Colab, or you can write. You can follow me and try to write your program. Okay, at first you have to get the data from this site, right? So we use the wget Unix command. Okay, so this one will be the Unix command wget, and you provide the URL as the parameters of this command. And once you run it, it will download the file to your VM. So we can wait for a while, and it's quite fast. So now we will have the file breast cancer Wisconsin.data. So this one, the file is here. Because it is the CSV file, so just import the pandas and import pandas as PD, and PD is df is panda.read CSV, and the file name is breast cancer Wisconsin.data. In the first stage, you can read and check that okay, the data is like it can be read correctly, but I think you can see that, and you can read from the UCI that what is the meaning of each attributes. And I can briefly tell you that the first one is the ID here, and that is the field of the diagnosis, that is malignant and benign. So, but this field is in the last field. So you can imagine from our data that now So there should be no header here, right? So we will redo it, but this time I'll set the header to be none. So it means that this file has no header. So let's run it, and you see that now we have the columns like 0 to 10. Okay, and the last one, you can see from here is 2 and 4. From data.name, you can go back to the UCI one, and here from the data folder, you can see that we have .names also. If you want to read in more detail, you can download this file, and I've already downloaded, and this is the values of the content of the file, and you can see that there is missing attribute values, 16 instance in group 1 to 6 that contain a single missing, and it denoted by the question mark. Okay, so maybe you can because this one is like the sample one, maybe you can fill in these values by many options, but I will tell you that in this stage I will drop the columns that contains the question mark, and we have two classes. The benign one is 458 and the malignant is 241. So the benign is the the major class, and the malignant is the minor class. So I'd like to start working with this one. So at first you have to check the question mark first, that do we have the question mark here. We have 699 rows, and look at this. So the way that you can check is you can check the of is equal to question mark and then dot sum, because false will be 0 and one true will be 1. So if you dot sum, it means that it will find the summation of all values here. So if there's some columns that has not 0 result, so that columns may contains the question mark. So let's see the result. So you can see that column number 6 indexed by 6, index 6 is here. It contains the question mark. So I will select it using the columns, the data series that we can choose more than one series, guys. This is the way that you can compare the values in the data frames, but of course we can do a lot of things of this, but I'll try to incrementally add something new to your to your think back. So to select more than one series, you can use the the list of the columns, because this is the series that we have, the name of the columns is like the integer. So actually it's not a good way to do something like this, because you don't know what is the meanings of this, but it's fine. It's fine to use it at this stage. So because I don't want you to worry about this, so guys, this is the easiest way. We have the columns like this. This one is the ID. So this one is the second attributes. That should be the first one, right? And this is the class one. The class. Oh, sorry. This one is not cannot be retrieved using the list, the normal list. So you have to provide the index number of your data. So guys, you can imagine that now we have 1, 2, 3, 4, 5, and in columns number 6 it contains the question mark. So our training data should contain 1, 2, 3, 4, 5, and 7, 8, 9. This one will be our training data. So our X will be the DF that it used the columns of I will show you the result first. If you want to choose more than one series, if you want to work with only one series, you can do it like this, right? But if you want to work at or filter more than one series, you can put it in the list. You can use the columns names, the columns name to be the member of the list. And then guys, look at this. I use the df.head first, and then I'll use 1, 2, 3, 4, 5, and 7, 8, 9 to be our series that we choose. So I put the list of the series that we need: 2, 4, 5, and 7, 9, 8, 9. This one will be the training data. Okay, so this one is our X. Okay, so our X will be these series, and our Y will be the last columns. This is the F10. Okay, so now we have X and Y. That's all. So now at this stage, we already have the data here. Okay, so we have to check the result from the data. You can double check with this one. It said that benign is 458 and malignant is 241, and you can see that it for the class for the last columns. The last columns has two positive classes, the benign and malignant. The values are represented using 2 and 4 in last columns. I try to find the result here. Oh, sorry. 2 for this one, 2 for benign and 4 for malignant. So guys, let's check. Let's check 2 for benign and 4 for malignant. Okay. Oh, a moment. I'll try to okay, remove this one already. Okay, so we will use the last series, df number 10, and check value counts. It will count all values in df10. That is, the benign is 458 and the malignant is 241. This is the one that was shown in this data, right? 2 for benign and 4 for malignant, and we have benign 458 and malignant is 241. So these two is benign and this 4 is malignant. Okay, so next I'll use the decision tree to train the data and build the confusion matrix. But the better way is we will divide it into the training and test. So we have one like the one library from the sklearn to be able to divide the data into the training and test. But this is the first stage. I'll introduce you the best, like the next step that is better. So at first, from last week, we use sklearn, right? From sklearn, we'll import the tree, and from sklearn.model model selection, where we import the train and test split. So once you import this one, it will be very easy for you to create the train and test. At first, I would like to create the train and test split. From this function, it will divide your dataset into X train, X test, and Y train and Y test. Okay, and then use train test split and provide X to be your data. Okay, and it can, like, if you want to repeat it again, you have to provide a seed for the random here. The option is random state. For example, I send it to be for 13. So this will be the random state that you can fix it. So once you run it now, anytime that you run, the data will be same if you use the random state, the same random state. So guys, once you finish it, you will have X train, X test, and Y train, Y test. A moment. Sorry. I forgot to send Y1. So this one is X, right? And now I have to provide Y also. Sorry. Now we have X train, X test, Y train, and Y test. So let's take a look at your Y train here. So you can see that Y train will be like the index number 142. Okay, so it should be same as the here Y test. So Y test is 175 data, and for Y train it contains 524. So the ID here should be same as the one in the X test. X train here. So you can see that the ID of your data will be in the index, and X train and X test must have the same ID. Okay, so next, this one is the random state to be 13. You can set random state to be 31, and you can see that the data now is different, right? The first one is 639. So if I change it back, guys, look at this. Okay, I try to close my screen batch option. Okay. So If I change it into 13, change it back to 13, this one is the result. So you can see that the first number, 142, come back here. So the random state is the number that if you want the same result, you can set this number to be the one that, like, the fixed one. So we have X train, X test, and Y train and Y test already. Next, we'll build a tree. Okay, so it's quite simple. I think you still remember, right? The classifier will be the three dot decision tree classifier, and we use the default option for this one. And you have to fit to create the model, right? So you have to send X train and Y train. And if you want to predict the result, you can use clf.predict and send the X test and get the Y predict values. Store it to Y predict values. So that's all. Now you already train and predict the values of the X test. Okay, so okay, so but we don't know the number of Y test that it's already like divided for us. So this one is Y test, and this one is the series, right? So you can use value counts. So I'll keep it like this one is B9, class B9 is 116, and for the malignant is 59. So this one is Y test and dot value counts. So I think you can get the idea. We have 116 benign samples and malignant 59. So now it's time for us to build the confusion matrix. The confusion matrix is in the library. Look at it. Look at this from sklearn dot matrix import confusion matrix. Confusion matrix, and you have to send the actual result first. The actual result is in Y test, right? This is the label, and the result come from the model is in Y predict. Okay, so this is the result that you can see. Okay, so I hope that you can still remember this one. Oh, sorry, a moment. This one is the actual label. This one is predicted label. So this one is class 2 and class 4. Class 2 and class 4. So the actual data of class 2 is 116, right? 111 plus 5, so this is 116 actual class 2. This one is class 4, 59, right? So this one is 59, 4 and 55, so the total is 59. So guys, this one is predicted to be class 4, right? Predicted to be class 4. And this one is predicted to be class 2. Okay, now we are ready. So you can see that this one you can get the confusion matrix from the sklearn already. And we have another one that is the more beautiful one. You can use almost same library, but from sklearn matrix. But this time you have to import the plot confusion matrix 1, and then you have to import matplotlib.pyplot as the PLT, and then you can use this function plot confusion matrix, and you have to send the classifier and xtest and the solution or the label the y-test, and you can force or show the display label to be the class 2 or class 2. I think you can still remember, right? Class 2 is benign, so you can use benign, this word. And class 4 is malignant, so provide to be the malignant. So it will be very easy for us to understand the result. Okay, so we can run it like this, and I will show you how can we modify it later. The display labels. A moment. Plot confusion matrix CLF, xtest and y-test, and display labels, maybe display labels. Oh, sorry, I forgot the equal sign. Okay, that's all. There's something strange here that is not nice because it's converted into the floating point display. So you can force it to be like the values format. It has one option that is the values format. Can you see the hint? So if you provide a value format, it will force the graph to be shown in integer. So you can see that we have 111 here for the benign class. So now you can see that now, or you can read the confusion matrix easier than the first version. Okay, or you can set the color also using the CMap to be the color, and you can use plt.cm.blues. This one is the color set. So now it's finished, right? So you have the actual benign 100 from the actual benign 116. You correctly classify it to be 111 and classify it in the malignant. 5 examples of the benign are classified as the malignant, and here this one 4 of malignant are classified as the benign. Okay, so at this point, after you finish here, now I think you can find all values in from our previous video clips. Okay, precision recall F1, true positive rate, false positive rate, true negative rate, and false negative rate. I think you can find it by yourself. Thank you very much.